everyone. Welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be talking about solving equations using addition and subtraction. Let's get started. Okay, so really quickly, I just want to take a minute and go over some of the terms and the words that we've been using lately. One of the words that we've been using a lot lately is the word simplify. And we see the word simple in the word simplify, and it just simply means to make smaller, not necessarily solve, just make smaller. We've also used the word term a lot, and a term is a number with a variable, like 3x or 2t. The example I have here is 4x. So it's any number with a variable. That is a term. Like terms, now we've also been using these words, and that basically just means that the terms in question have the same variable. For example, 4x and 5x. That's what we're talking about when we say that two terms are like. They have the same variable on the end, like we have here with the x. 5x and 4x, that would be like terms. How do we simplify expressions? So to simplify expressions, we can combine like terms, and it's actually pretty easy. Let's take a look. Remember, like terms have the same variable. So if we have, let's look at our first example, 4x plus 5x, well, that's pretty simple. If we know what 4 plus 5 is, then we can do this problem quickly and easily. 9x, because both the 4 and the 5 have the like term of x. So 4x plus 5x equals 9x. How about this one? 6x plus 2y. Can we combine those terms? No, we can't, because x and y are not the same terms. They are unlike terms. So in this case, we have to leave this exactly as it is and just keep saying 6x plus 2y, because they are not like terms. So let's look at some more examples when we're talking about expressions with like and unlike terms. So here's another example, 7x plus 2x plus 5y. Well, you can see here we have some like terms and some not like terms. 7x and 2x, those are like terms because they both have x. So we can add those together. We can join those. 7x plus 2x equals 9x. But can we add the 5y? No, because that's y. It's not x. So we can just simplify it enough to say that 9x, change it into 9x plus 5y, because 5y is not a like term. We can also do this with subtraction. We can say 9y minus 2y equals 7y. And sometimes we can add and subtract like terms. Here we've got 8x minus 3x plus 2y plus 4y. So we've got the 8x and the 3x. Those have like terms, so I can subtract the 3x from the 8x and get 5x. And I can add the 2y to the 4y and I get 6y. But I cannot combine 5x and 6y because those don't have like terms. One has an x and one has y. All right, your turn. Take a minute, see if you can combine like terms. Be careful, don't include the terms that are different. All right, everybody, how'd you do? Let's take a look at the first one. We have 7z plus 2z plus 4z. That one was pretty simple. All you had to do was add up the actual numbers because they all had z's, and you should have come up with 13z. The next one, 25y minus 13y, 12y. 7x plus 2x plus 4a. Now here we have kind of a mixture of things going on because we've got 7x and 2x, which I can combine because they have like terms, and it gives me 9x. But the 4a, a is not x, they're different variables. We'll just continue that on the other side of the plus sign. So we just have now 9x plus 4a. So when we're solving single variable addition equations, I just wanted to take a minute and make sure that you are feeling very confident that you are able to write a phrase as an equation. And this is particularly helpful with performance tasks or word problems. So let's take a look at what I'm talking about here. If you have these words written out, 5 plus an unknown number is 10, it's really important that you practice writing phrases into the form of an equation. So if I want to think, when I see 5, I know that's going to be 5 plus, that tells me I'm probably going to add. Unknown number, remember we discussed the word variable, is equals 10. So if you need to, just continue to practice writing phrases out as equations. And so this sentence would be written as an equation as 5x plus 10. Now, if we needed to solve for that x, we could probably do it using mental math, because 5 plus something is 10. We all know that the value of the variable x is going to be 5, just mentally. But how do we solve when we have a little bit more complicated problem, when it's not so easy to see what the value of your variable is going to be? Well, I will show you. The way that we would find the value of the variable is by doing something called using the inverse operation, and I'll show you what I mean by that. Here's the actual definition of inverse operations and how we solve, because we want to isolate that variable and solve to find out what the value is of that variable. So here we go. To solve an equation using inverse operations, do the opposite of the given operations on both sides of the equal sign. So, and I think it's easier to just explain this to you in a problem. We have x plus 27 equals 43. Now the operation they're giving us is plus. If I were to do the inverse operation, the opposite of addition is subtraction. So in order to isolate my variable x, I'm going to do the opposite of what's written in the equation. So instead of adding, I'm going to subtract. And I have to do the same thing on both sides of the equal sign. So subtract 27, subtract 27. 27 minus 27 equals 0, so that's good. And look what I've done. I have now isolated my variable. Great, that's what I was trying to do. And now I simply solve this operation. 43 minus 27 equals 16. And there you go. I've got the solution. I have a value for my variable x, which is 16. All right, your turn. Try to solve for the variable. You've got 45 plus x equals 67, x plus 16 equals 22, y plus 15 equals 30, and x plus 12 plus x equals 18. So try to solve for x, or try to solve for the variable, whatever that variable may be, and remember to use the inverse operation. Good luck. Okay, everyone, how'd you do? Let's take a look at our answers here. All right, looking at the first problem. I have 45 plus x equals 67. So I want to subtract 45 from both sides of the equal sign, and that tells me that x equals 22. Here's another one. X plus 16 equals 22. Subtract 16 from both sides. X equals 6. Y plus 15 equals 30. Subtract 15 from both sides of the equal sign. Y equals 15. And our last one, 12 plus x equals 18. Subtract 12 from both sides of the equal sign, and x equals 6. Not so bad. Once you practice using inverse operations, you'll be able to do it pretty much without even thinking about it. And subtraction is actually pretty much the same thing. The inverse operation of subtraction is addition. So let's take a look at some of these. This problem asks us x minus 12 equals 40. If I want to find the value of that variable x, I need to do the inverse operation of subtraction, which is addition. So I will add 12 to both sides of the equation, and I'll get x equals 52. How about this one? X minus 9 equals 22. I'm going to add 9 to both sides of the equal sign, and I get x equals 31. And once again, x minus 7 equals 23. Add 7 to both sides of the equal sign, and you get x equals 30. All right, guys, that just about wraps up the lesson for today. Thanks so much for joining us, and we'll see you next time. Bye-bye.